Rosie and I are going to do some exploring. Just about ready to go. Yeah, we got sunscreen. And I got my canteen. I got a cell phone. And I got my canteen. I got some granola bars. And I got my canteen. So, Rosie and I are ready to go. So we head out. Well, let's go. Oh, I got my canteen.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T-minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by the Dromedary LX from Kobe Motors.
It's a desert. Now, about 1 out of every 5 places, a fifth of the land on Earth, is a desert. They receive very little rain or snowfall, so they're always dry. And the things that live here have adapted. They have special ways of managing their water. See, deserts aren't hard to find. It's around here somewhere. Hey, it's right here. Hey, look, here it is. I know it's around here somewhere. I thought it was right here. Oh, excuse me.
I've been through the desert. No, it's an ecosystem. I've been through the ecosystem
Now, where was I?
The desert.
Oh, yeah. Deserts aren't hard to find because they're part of a worldwide pattern of weather, a dry pattern. And the things that live in deserts are used to very dry ecosystems. Take a look at this. It's a model of the Earth as we see it from space. It's a globe. And here in the Earth's middle, the equator, the world gets the warmest because the sun shines directly. Now, it's the warmest, but it's not the driest. The air near the equator gets warmed by the sun, and it gets moist because the ocean is here. And the warm, moist air gets squeezed up by cold air from the north and south. As it goes up, it spreads out. When it spreads out, its warmth spreads out. So it gets cool. It starts to rain. And the rain falls right here near the equator. Most of the world's jungles and tropical rainforests are found near the equator. Now, the dry air happens by the time it gets up here and down here.
Deserts are to be found all over the world, but many of the best known lie between the latitude of 10 north and 35 south of the equator. Here, we find the combination of cold ocean currents and mountain barriers that create desert conditions. We define a desert as an area that receives less than 10 inches of annual rainfall.
All right, friends, let's take a look at our extended forecast, and it shows some changes coming in the next few days.
Psych! It's not going to change. It's still dry and hot. Yes, my friends, the forecast never changes here, but
The sponsorship never changes either. Genghis Khan, blah, blah,
Let's see
blah,
what's
blah,
next. This layer of fog above this warm pool is like a layer of clouds above the ocean. When the wind blows, the air moves up the mountains. And when it goes up, it spreads out. When it spreads out, it cools off. So it's up here that it rains and snows. By the time the air gets over the mountains to this side, well, it's pretty well dried out. So over here, it's wet and green with plants. Over here, it's dry. brown with bare soil. This is how deserts are formed all over the world.
I've been through the desert on a camel with no name. No, wait. I've been through the desert on a chameleon with no name. I've been through the desert on a dune buggy. That's not it. I've never actually been through the desert, but I know it's a large area of land that gets very little rain or snow. You might think that just because a desert is hot and dry, that it's lifeless. No, far from it. Whole ecosystems have developed where things live on very little water. Take it, Earl.
Some plants send their roots out deep and wide looking for moisture. Other plants make seeds that can sit out the dryness. When it rains, they grow flowers that make more seeds. Where they're plants, they're animals that eat plants. And animals that eat the animals that eat the plants. They've got ways to make the most of a little water, too. For example, there's a beetle that props its body up at night. When the desert fog rolls in, moisture condenses on the beetle's body and drips down, and the beetle drinks it.
Save some for me.
Not bad. Some desert animals, like the desert rat, clean themselves by taking a dust bath. They don't use any water at all. They get dry clean. Other desert animals burrow themselves into the sand to cut down on their water use and stay cool during the day. You know, I could go for some water right now.
There you go. Don't drink that all at once, you'll fill your head up. You want a sandwich with that?
She knows they're hot, she knows they're cold, but she lives out here 'cause she's so bold. She's desert girl.
You know, I went through the desert on a horse with no name. You know what I learned? That song sucks. Did you hear me? Are you listening? Are you listening to me? How can anyone go through the desert and not name their horse? We got John, we got Paul, and George, we got Ringo. What else? It's windy in the desert.
Come on, sing along. Come on, you guys.
Hot deserts are cold at night. Please consider the following. The night in the desert is cold because there's nothing to hold in the heat. Take a look at this. It's our desert temperature simulation system of science. And this tub of sand is like the desert floor. It's a sandbox. And this, keep those french fries warm light, is like the sun. And here is a temperature probe. Oh,
Careful. Careful.
And here's the thermometer. Right now it says 122 degrees Fahrenheit. That's an old way of measuring temperature. It's about 50 degrees Celsius. So here's daytime, and it's hot. At night, the sun doesn't shine. So this black metal plate with the ice above it represents the night sky. It's the icy blackness of space. The icy blackness of space. So down here, the heat that's in the sand, in the desert floor, is facing the night sky. The icy blackness of space. And you can see that the thermometer is going down. It's going down pretty fast. Right now, it's about 104 degrees Fahrenheit. That's right around 40 degrees Celsius. Now, if you don't believe me that it's the cold metal plate, the icy blackness of space, that's making the temperature fall really fast, watch this. This represents clouds that might roll in over the desert. Now, keep an eye on the thermometer. See, there are clouds in most parts of the world, and most parts of the world don't go through the temperature swings that we see over the desert. There. It's starting to go back up. Just like that. See? Now, I didn't bring in the keep those french fries warm light again. It's the heat in the sand that's making the thermometer go up. The clouds are acting like a blanket to hold the heat in over the desert. See, clouds would keep the desert warm at night, but the desert doesn't usually have clouds. It usually faces the night sky. Icy blackness of space.
You're starting to scare me.
No clouds in the sky, no water on the ground, makes the desert cold at night all year round. Anyway, thank you for joining me on Consider the Following.
Check this out. I did this really cool experiment with a leafy houseplant and a desert plant, like a cactus. I covered them both with plastic bags and had a string around them, and then I put them in the sun for a while. See these little water droplets? That's the amount of water that a leafy houseplant gives off to the air.
And see how the cactus isn't giving off any water. That's because it lives in the desert and it saves all its water for a time when it really needs it. It's an awesome experiment. You should try it too. Try it!
These are saguaro cactuses. Saguaro cacti. Saguaro cacti. Saguaro cacti. You probably recognize them, just like that. I mean, like that. That's because they look like cactuses. They're green and big. And right here, they're pretty far apart from each other. That's because they can't be as close together as you might think of trees in a forest because there isn't as much water. When you're a cactus, saguaro cacti. Water is what it's all about. See, the cactus has no leaves, even though it's a very large plant. This one weighs several tons and is a few hundred years old. See, leaves are too thin and spread out. Water would evaporate off them too quickly for life in the desert. So instead, cactuses are green all over. The whole plant is absorbing sunlight all day. And it's filled with water. It's a spongy tissue that's wet inside. Water is your focus. And because water is so precious in the desert, water is what it's all about. Cactuses don't want any animals coming along and poking holes in them to get the water out. So they have these famous spines, which make it very hard to reach in to get to the green part. There, see, you see the spines? Right there? You see them?
My name is Wendy Hodson, and I'm a scientist that studies plants, and not just any old plants, but desert plants. Deserts are dry. You don't have the water available to the plant. I like to study not only what plants are here and where they're found, but also how these plants adapt. It's a hot job, but somebody's got to do it. This is Engelmann prickly pear, and it is a common cactus in our Sonoran Desert. And even though it is common, I don't think it's been collected from this area. So I'm going to make a specimen of it and put it in our herbarium, because these spines do hurt. And you have to be very careful. That's why people don't collect them very much. I've cut open this prickly pear pad to make a specimen, and you can see the inside. It's very moist, it's very sticky, and this moist tissue helps keep the prickly pear pads from drying out. This is one of the many adaptations that this and other desert plants have developed to deal with the very dry conditions of our desert.
This is a sand dune, the middle of the desert. Now, most of the world's deserts aren't sandy at all. 20% of the world's deserts are covered with sand. The rest are covered with desert soils. They're usually hard, sometimes called hardpan. Hardpan. It's hard. It's desert soil. Now, desert soils can be full of clay and stiff. They can be white and chalky, full of chalk. They come in all different colors, but all of them are dry. They have very few living things on them, and therefore there's very little stuff in the soil that comes from living things. Desert soils do not have very much material in them from decaying plants and animals, dead living things. No, that's because there aren't many things living on top of the soil. That's because it doesn't rain very much. I mean, it's dry. It's a desert, for crying out loud. This part of it's sandy, though, I'll tell you that. Whew.
Arid winds dry the land and create swirling dust clouds. For thousands of years, the winds have removed what surface soil existed, leaving behind rock, gravel, and sand.
Hey, Bob, you're sweating like a pig.
I know. I've been thinking of getting my sweat glands removed.
Hold on, Bob. Not so fast. Try my Desert Extra 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 Dry.
Desert Extra 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 Dry?
Desert Extra 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 Dry fights wetness the same way nature creates deserts, by building up ridges that make moisture fall before it can reach your underarms.
Will it keep me drier than a prairie dog's butt?
Why do you think they named it Desert?
Thanks, Bert.
You bet, buddy.
I'm here to tell you that not all deserts are hot. Some are cold, icy cold, freeze you to the bone cold, shivering, frostbitten cold.
Whew. Some of the driest places on Earth are also some of the coldest, like near the South Pole in Antarctica. See there, the sun just grazes by the Earth, and the wind that blows has very little moisture in it. Take a look at this. It's our dry, cold air environment simulator of science. And we have 2 gauges. Now, each gauge has 2 dials. It has a thermometer and what's called a hygrometer. A hygrometer measures the amount of humidity in the air, the amount of moisture, the amount of water vapor. So here in the room, it's about 20 degrees Celsius, and the humidity is right around 70%. But in here, it's the same air as in the room, but we've packed it with ice, so it gets cold. The air is very cold. In fact, the thermometer is off the scale. It's way below 0 Celsius. And the hygrometer, the humidity gauge, shows only 40%, way less than the humidity here in the room. That's because when air gets cold, it can't hold as much moisture, can't hold as much water vapor. The water freezes out. It becomes ice there on the inside. Now in Antarctica, it's way colder than this. Way colder. The air is so dry, there's places where it hasn't snowed or rained for over 100 years. When you see those pictures of big chunks of ice, that's old ice. It's been there for centuries. See, down there, it's dry. It's cold. It's a desert. It's nice though. It's that dry cold.
Bummer.
There are places on this here planet where you have to be alert. When you go there, you have to plan it. I'm talking about the desert. There is little rain or snow. You might ask yourself why. Something you should already know is deserts are always dry. Animals and plants have found ways to store water, and camels can go dozens of days even when it's hotter. From Antarctica to the Sahara, just ask the snake or the cacti. If they could talk, they should tell ya. Water's in short supply, deserts are always dry. But don't be fooled about the desert. It's not always hot like you're told. Or full of cactus, snakes, and dirt. Some deserts are even cold, but not a lot of water there. The main thing that I am told, from Antarctica to the Sahara, just ask the snake or the cacti. If they could talk, they should tell ya. Deserts are always dry. Just ask Bill Nye.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some vascular bundle transpiration strain ratios to wrap up. See ya.
Produced in association with the National Science Foundation.
Desert. Sandy. Far as the eye can see, doggone it. Over there, some sage. That's where your transpiration vascular bundles are, right out there. Right there. Yeah, another day at the office. I think I'll sit like this. Now the room in this air, the air in this room, and my cheeks ain't tan. Take a look at this. It's our desert temperature system. It's not. I know every trail in the Lone Star State because I got the